In this last part of the limits section, we are going to cover how to read a limit from a graph. We talked a little bit about doing it by hand and a little bit by doing it by approximation. On these examples, as you can see, we will be finding the limits from the graph given of the function. This is example 6 out of the limits notes. I'm actually going to break this problem down into the actual directional limits. So as you can see, I've got a copy of the graph, and I've actually broken down finding the limit at 0, 5, and -7 by doing the directional limits. So let me get this where we can see it. So we're first going to look at 0. X is 0. We're going to look up the function value. And as you can see, we have the right-hand limit approaching from the right, the left-hand limit approaching from the left, and the overall limit. So as we're approaching 0, x equals 0, from the right, it appears that the y value we're approaching is 2. So the function value, as we get closer and closer to 0, the function is getting nearer and nearer to 2. So my limit approaching from the right is 2. It will also be 2 coming from the left, because notice the curve's coming up towards a y value of 2. So in both cases, as we come from the right and the left, we get a limit of 2. Those are in agreement. So my overall limit is 2. Now at -7, notice that coming from the right, again, we're approaching what appears to be -4. And coming from the left, same thing. It appears that our limit is approaching, the limit of the function is approaching -4. So again, we have agreement. So in these first two examples, we actually do have a limit. And the first one, it's 2. And the second one, it's at -4. Even though we have this odd point that's up here. I actually do this example in the continuity section, and we talk a little bit about the significance of that point being where it's at. To finish out, let's look at the last example, which is at 5. And notice at 5 we have an asymptote. And coming from the right, it appears that the x values are getting extremely small and quickly, and this is going downward. So our best description would be that we're approaching negative large values that kind of go without bounds. So this is basically approaching what we would describe as negative infinity. However, on the other side of the asymptote, it appears that the curve's approaching this hole, which is undefined, but we still go by, what are we getting nearer and nearer and closer to, and it appears that 2, 3, 4, that our limit is actually approaching 4. But as you can see, there's no agreement here. So this limit does not exist at 5, because the left and right hand limits are in complete different disagreement. So going back to example 6, now that we've done that, I'll give you a second if you want to copy that or pause. We kind of can fill in the blank. We discovered that at 7 it was -4, and I guess I didn't go the exact same order, but we can decipher which one we did. And at 0, the limit was 2. Recall here it was 2. Here it was -4, but here it didn't exist. I'll put D and E. To complete parts D and E, the limit at 0, or the function value at 0, is just going to be 2. And at -7, it's actually going to be the point, which is 1, 2, 3, 4, 5, 6. So f of -7 is 6. So I'll leave that up for a second if you want to pause it or copy it. These last two examples I'm going to do just deal mainly with how to find limits at an asymptote. So this is the same as example 3 in our notes. So we're trying to find the right-hand limit, the left-hand limit, and the overall limit at 2. So approaching from the right to the left at 2. Well, if we look at our asymptote, which is right here, kind of like a boundary that splits the curve into two pieces, it appears. But coming from the right, so the right piece of the curve appears to be going up without bound very quickly. And again, anytime you have this situation where the curve's going upward and it appears that it's just, going to go up, or I'll describe it as without bound, we will describe that as positive infinity. So that curve, that value just keeps getting larger and larger and larger. It really doesn't have any bounds, so we're going to describe it as infinity. On the other side of the asymptote, basically the same thing happens, but we're approaching very large negative values. So we'll describe that as negative infinity. Positive infinity and negative infinity do not agree. So we have to say that in this case, that the limit does not exist. As well as the function value, we have no idea what that function value is at -2. Since it is describing the function value, probably to say it's undefined is a better answer. Although in a sense it doesn't exist is true. But typically when we have a function value, if it doesn't exist, we just say it's undefined. Okay, one more example dealing with curves and limits and dealing with the asymptote. In this one, notice that we have an asymptote at 2 again, but on both sides of the curve, it appears to be going upward. So in this case, A, we would describe the limit as x approaches 2 from the right. We would again describe it as positive infinity. Looking on the left side of the limit, again, it appears to be approaching positive infinity. And in a sense, we have agreement here. Since both these limits appear to be let me zoom out a little bit. Let's see. There we go. Probably down, went out too far. But it appears that both limits are approaching, both directional limits are approaching positive infinity. So the overall limit is positive infinity. Now I'll zoom in so you can see it a little better. And that concludes the limits part for doing the limits graphically. So continue to work WebAssign problems and book problems and email me if you have any questions.